Hello viewers, let us see on topic class P and NP problems from the 5th unit of Theory of Computation. And the objectives are to understand the properties of class P and NP problems. First of all, problems that can be solved in polynomial amount of time are called as tractable, and the problems that cannot be solved in polynomial amount of time are called as intractable. There are several reasons for intractability. That is, sometimes the instances of the problem will be very big, very large, so we can't complete the problem in polynomial amount of time. Second, although there might be the huge difference between the running times, so it will leads to it is depend upon the parameter of the polynomial function, which is nothing but n leads to n will determines the based upon the input size. So if it is large, huge value, then we can't complete the problem in its time. So it leads to intractability. And third, polynomial functions possess many convenient properties. In particular, both the sum and composition of two polynomials are always polynomials too. Fourth, the choice of this class has led to a development of an extensive theory called computational complexity. Now, a class P problem. Class P is a class of decision problems that can be solved in polynomial time by deterministic algorithms. This class of problems is called as polynomial class. And these problems that can be solved in polynomial time as a set that computer science theoreticians called P. A more formal definitions of P include decision problems, which are problems with yes or no answers. The class of decision problems that are solvable in O of function, polynomial function, in polynomial time, where P of n is the polynomial of problems input with the size n. And there are many types of problems in that category. Class P problems, they are searching, element uniqueness, graph connectivity, graph acyclicity, primality testing. Now, the restriction of P to decision problems can be justified by the following reasons. First, it is sensible to exclude problems not solvable in polynomial time because of their exponentially large input. And many important problems that are not decision problems in their most natural formulations can be reduced to a series of decision problems that are easier to study. For example, instead of asking about the minimum number of colors needed to color the vertices of a graph so that no two adjacent vertices are colored the same color. So this problem is called as coloring problem. Coloring of the graph's vertices with no more than m colors for m is equal to 1, 2, etc. So every decision problem cannot be solved in polynomial time. Some decision problems cannot be solved at all by any algorithm. Such problems, unsolvable problems, are called as undecidable problems. But decidable problems can be solvable by algorithm. The decidable problems are otherwise called as halting problems. Now we can see non-polynomial time algorithm. There are many important problems, however, for which no polynomial time algorithm has been found. The example problems are Hamiltonian circuit problem. It will determine whether a given graph has a Hamiltonian circuit. That is, Hamiltonian circuit is a path that starts and ends at the same vertex and passes through all the other vertices exactly only once. Now, traveling salesman problem. It is one example for non-polynomial time algorithm problem. Traveling salesman problem, find the shortest path through n cities with non-positive integer distances between them. The knapsack problem, it will find the most valuable subset of n items of given positive integer weights and values that fit into a knapsack of a given positive integer capacity. Similarly, partition problem, bin packing problem, graph coloring problem, etc. Integer linear programming problem. This is another one kind of problem. It will find, this is also comes under the non-polynomial time problem. This problem find the maximum value for a linear function of several integer valued variables. If the linear function may have several integer valued variables subject to a finite set of constraints in the form of linear equalities and inequalities. Now we can see another one definition. A non-deterministic algorithm is a two-stage procedure that takes as its input an instance of a decision problem and does the following. It will do non-deterministic stage and deterministic stage. Non-deterministic stage means an arbitrary string is generated that can be thought of as a candidate solution to the given instance. In the deterministic stage, it will take both I and S as the inputs and output the result either yes or no based upon the acceptance, based upon the return value of the algorithm, whether the input can leads to halt state or not. The non-deterministic algorithm is said to be non-deterministic polynomial if the time efficiency of its verification stage is polynomial. Now, class NP. Class NP is the class of decision problems that can be solved by non-deterministic polynomial algorithms. Now, a decision problem D is said to be NP complete if it is hard as any problem in NP. So the problem D belongs to the class NP. Every problem in NP is polynomially reducible to D. That's all about the topic. And the possible university question is to explain class P and NP problems with examples. Thank you all.